Sorry if you were in the middle of listening to me. Okay, we should be back. I'm just waiting a second to see if MS Streams will come back online for me. Well, I know I'm online on 2 other venues. I know I've got about 60 people watching right now. So in the interest of continuing to talk in a kind of roughly live way, it seems like MS Streams should be working, but it just doesn't want to. Very strange. Back to labs. There's online and offline labs in this course. I know a lot of you folks will be remote students, definitely offline. We have 2 different kinds of lab slots available. One is in a room, which will be in person, and one is in a remote session on Microsoft Teams. You will have to sign up for these different lab slots and make sure you go into the one which actually suits you. So if you're remote, you'll need to go into an online lab. If you're available here in Canberra, you need to go into an in-person one. You're very strongly encouraged to attend your weekly labs. The sign-ups are open later today at 2 p.m. So each week we do lab exercises that are both art and code challenges or tasks to work through, and these are the skills you need to work on your assignments and major projects. So the labs are also a making session. The labs, we'll talk about this in a minute, but for each lab, starting in week 2, you'll have a little exercise to do before the lab session, and you need to get that done before the lab, a little writing task which you will put onto our course forum. And then during the labs, there'll be some tasks which are kind of the assessment tasks. They're quite easy to meet all of those assessment tasks, but it's just a matter of making sure that every week you're in those labs learning these important skills. So in this course, in these labs, we do 2 things. We build you up with new knowledge, and we break everything apart and try to explore new ideas. So they should be really fun for you, actually. Now, here's a thing that you need to do. This is the first to do for this week. The week 1 lab is actually a sort of pre-lab on your own session to get your computer organized. Make sure you have all the software you need and you understand how to use the tools for this course. So you can do this content right now. I'll talk a little bit more about that later, but we have a drop-in session later this week. It's on the labs page for the course website, and you can figure out how to get your computer set up. If you can't do it on your own, you can also ask questions in the forum. Now, the reason we have this pre-lab before labs, week 1 starter session, is to make sure that you're really on top of the bits of software in this course. I've had a student in a previous year say, Charles, there are like 6 different software packages to get a handle on in the first week. I know that's a lot, yeah. Microsoft Teams, GitLab, Visual Studio Code, the P5 system. It's a lot, and particularly if you're coming from a non-computing background, you suddenly have a lot of new bits of software to use that at the starting point doesn't make any sense. What I want to say is that I know that there's this uphill battle for that. It's like that whenever you want to learn something new, that there are a lot of unfamiliar tools to get into. And we need to get everyone in this course just to this kind of basic level of understanding of the tools. So that's why we've got this very easy first week lab for you to get in there and try to make sense of these tools, ask questions when you need them. And definitely by week 2, if you're still having issues with the tools, talk to your tutor about it, and they'll be very interested and very helpful in making sure that you get everything right. I know there's folks on Microsoft Stream still having issues. I can't really address that right now, but we can move forward. If you have the ability, look at this on YouTube or Twitch, and if you can't, it'll be on Echo 360 later. So what are the assessments for this course? Let's talk about the assessments. Very important information. The first assessment starts in week 2, and it's your lab tasks. So over the whole course, there'll be 10 labs that are each assessed, and they'll each contribute 0.5% of your final grade for a total of 5%. You'll have to do 2 kinds of tasks, as I said before, the pre-lab task, which is a writing task you post on the forum, and the in-lab tasks, which will be code, discussions with other students, collaborative tasks, and they're marked in your lab. So you need to go to your labs to do the in-lab tasks, and you need to make sure that your pre-lab tasks are done before your lab. You actually can't do them during your lab, you can't do them after your lab, they're due the minute your lab starts. So in order to get full marks for this part of the course, you need to have done that before the lab each week. You need to go to each of the 10 important labs starting in week 2 and doing all the lab tasks. All the lab tasks are easy, they just require you to be engaged and collaborative, present in your lab. This is particularly a challenge when you're online, so make sure that you're ready with hopefully with a webcam, hopefully with a microphone, ready to collaborate with other students, because some of our tasks we say find a pair up and go and do this task and make sure you're working together. And if you don't do that, well, you won't have completed the lab task, so you won't get the mark. Why do I do these lab tasks? Why don't I just give you a big exam or something? Well, the idea of the lab tasks is to come up with good ideas, get folks together, collaborate, and connect between the coding tasks that you have to do practically and with the stuff I talk about in the lectures. So it's connecting thinking from lectures to expression, which is what you're doing in labs. And you'll need to submit your lab tasks on the forum. Just give you a little preview of the forum right now. Have to log into the forum. You'll have this experience as well. Logging into the forum, here we are. Comp 1720 forum. And first of all, I'm in the sort of top level category for Comp 1720. I can go into the pre-lab category. This is where you post your pre-lab work. I'm just going to do one. Charles's week 1 pre-lab. Here's my pre-lab writing task. Blah, 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 blah. By the way, you don't get marks if you do blah, 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 blah for your lab task, but I guess I get lecturer marks for showing you how to do it. So the important thing here is that I've posted my pre-lab writing task in this pre-lab sub-forum part. If you don't post it there, we can't find it later because the forum quickly gets full of thousands of posts. So everything in the pre-lab area should be a solution to your pre-lab task. And actually, as part of your pre-lab, you should also find 2 other posts from other students and leave a comment on them. So our tutors will contribute a few maybe pre-filled lab tasks just to show you how to do it this week and give you something to comment on if you're early in week 2. Okay, back to the lecture. First one's due in week 2, so there'll be someone with a due date of their first lab task very early next week. So make sure you're thinking about it if you end up with a lab early in the week. Assignments, next big thing. I told you this course was mainly about making. All of the assignments are actually in some way the same. They are make a work of art with the systems that we present you with in this course. There are 3 assignments. Each one is worth 15% of the final grade, 15 marks. And actually they do sort of escalate in difficulty. The first one is just to make a kind of static artwork, draw something in P5 with some specifications. The second one is an interactive artwork. And the third one is an interactive artwork that will have a kind of curve or a story behind it to bring the viewer through an idea. In this course, we don't use Wattle for submitting code. We'll actually be using GitLab, which is a code kind of management system that computer scientists and programmers use to store code and share it with each other. So when you send an assignment to us, you're storing some code that you've written on our GitLab system, our GitLab website, and then we can access it. We can access it to market. So you can't be sending us zip files. There's no way to send things through Wattle. You have to use GitLab to submit code in this course. And we train you to do this from week 1. The week one lab, someone just posted a funny comment on Discourse, which is quite amusing. The week 1 labs get you to do the same process on GitLab, which you'll do for all of your assignments. Now, just to maybe freak you out, assignment 1 is actually already available. Goodness me, it's due on 9 p.m. at 9 p.m. on Monday, August 16 in week 4. And your job for that assignment is to make a name tag or a kind of square profile picture. So we'll probably discuss assignment 1 a little bit in a later lecture. Maybe next week we'll talk in detail about it, but you can go to the website, go to the assessments page and see assignment 1. It's all there for you. If you want to just do it today, feel free. It's available for you to do. But we will be talking about it in more detail over weeks 2 and 3. I know it seems like it's due early in the semester, but it's really a very easy assignment just to get you started with the basic tools that we're talking about in this class. Now, the main piece of assessment for this course is the major project, worth 50%. I said this was a course about making, so I want to assess your skills at making interactive art, understanding and knowledge and skills through your ability to create an interactive artwork, which is what your major project will be. Once you've submitted this, it will go into our online exhibition. It's really fun. You go to a website, you can see everybody else's major projects and have a great time playing with them. I'll be announcing a theme for the major project next week, and then we'll sort of release the information about it. But it's a significant piece of assessment, and it will take a significantly larger amount of time than the assignments. The good thing is that maybe the last 3 weeks or so of the course, 3 or 4 weeks, we really focus in the labs on developing your major project idea. Every week you'll be asked about what your major project idea is. You'll be slowly building it up and creating something really, really good. Well, someone's just started a meeting, which is interesting. I'm not going to join that meeting. Now, the Comp 1720 forum, I've already shown you this. This would be the best and quickest place to get help in this course. If you want my attention about a problem that you have, send me a message on the forum. Don't send me an email. I get a lot of emails and it's easy for them to sort of disappear, particularly if someone's asking me a hard question. But if I get a message on the forum, or you send a message even better to the Comp 1720 admins, have a look at our communications page. You can get a pre-filled link to send a message to me and all of the tutors at once. Then there's a lot of people paying attention to it and you get help a lot faster. The code of conduct for our forums is be excellent to each other. That's the flippant short version. The longer version is that we don't accept any harassment in any kind. And we take it upon ourselves to manage the forum, moderate the forum, and if we see anything which is inappropriate, it will be removed, and we will certainly look into removing students' privileges from actually posting on the forum if they are not able to behave within our accepted practices. I haven't had that happen yet in this course. Everyone does seem to be excellent to each other. So it's not something to worry about too much. Finally, I know a lot of courses at the ANU will use Wattle. In fact, every course will have a Wattle page, but there's not much on our Wattle site. It actually is just a link to our real web page, or a bunch of links to different parts of our real web page. So you won't be using Wattle so much in our course. Just get used to going to our cs.anu.edu.au web page, which is linked from the Wattle and many places on Teams, on the forum, etc. Now in this course, we are making works of art, and you might find as we're going that I point you to things like a page of examples of artworks made in this same language we use called P5, the same framework, example code. Maybe people go out and find some images that they'd like to use, or some text, or be inspired by something, and that's fine. I really want you to be incorporating elements of the world that you find, whether it's images, sounds, fonts, text, colors, I don't know, bits of code. Sure, incorporate them into your artwork. But if you do so, you must reference it, because all of your submissions are university assignments, and that means that I expect this high level of referencing that we expect in any other course, including computing courses, but also in other colleges, in arts or humanities courses, in business courses, in social sciences, in science. I expect highest quality referencing. So anything you've taken from another source needs to be listed in a special file we provide you called the Statement of Originality file, where you'll list everything that you're referencing in your work. And the point of this is that if you haven't got anything in there, we're sort of assuming that you're presenting this as your own work. And if I find out that you've presented something from the internet as your own work, then it's actually plagiarism. And that's something which I have to investigate. So I don't want to do that. In fact, it's very annoying and frustrating when this happens, particularly when students just say, oh, I didn't know I had to reference this image that I found on Google. I just found it on Google. Well, you do have to reference things, and hopefully you found it from a source which has given you permission to use these images. We'll talk more about that later, but you have to be very careful when you're taking images or sounds or elements from online. So I just wanted to put this slide up. I know that we sometimes, if I use a word like plagiarism or academic misconduct, it can sound like quite scary terms, but I want to note that there's sort of different levels of badness, and often I see behaviors like, particularly in this course, copying work from a source without citation will be something that happens. I've taken this image off the internet, and I haven't said in my statement of originality that I didn't create it. Well, that's absolutely not okay in a university assignment. You must let us know in your references that you haven't created this image. And of course, if you've got an assignment which is all from images from the internet, maybe that's not quite as good as an assignment where you've created all the images using the skills we're teaching you in this course. So that's something to think about as well. I tend not to see too many very bad kinds of plagiarism, like buying, stealing, or borrowing others' work, paying someone to do your work. I'm sure that that happens sometimes. When I catch it, it's a very bad scene, but what I'm more likely to see is folks just misunderstanding what they need to reference. It's something we need to get right from the very first assignment. So that's this slide. Now, hot quiz, first exam worth 0 marks. Yeah, someone's asking about question in preferences for reference. There's detailed instructions in the assignments, in the FAQ, and where do I find my assessment timeline? Where do I find the lecture slides? Where do I find the lab content? Where do I find the late submission policies? The answer to all these questions and more is the Comp1720 course website, cs.anu.edu.au/courses/Comp1720. It couldn't be easier to find those answers for you. A little bit more admin. Let's talk about expectations. I know this is a big admin information dump of a lecture. What can you expect from us in this course? Well, we aim to have a very responsive communication policy. I'll show you about the labs in a minute. We aim to have a very responsive communications policy. We have this thing called the communications policy, which is sets out exactly how you can talk to us in this course and get a response quickly. It boils down to ask for help ahead of time and ask on the forum. If you're sending me emails, they get lost in my inbox. If you send something on the forum, my tutors and I will all be checking it together basically every day. There'll be a lot of activity on the forum. You might actually find that your question's already been answered, or you might find that there's a link to the website with the answer. You can also expect us to give you a lot of support in realizing an artistic vision, especially for your major project. And I know that that can be a big hurdle for some folks. You might get a handle of the technical stuff in the coding, but then think, but how do I make a work of art? That's going to be pretty tough. Well, we've been through this before. This course has been running for a long time. We've had thousands of major projects created, and everyone creates something. Everyone gets there in the end, particularly when they ask for help ahead of time and engage with the labs. What we expect from you? Well, I expect you to engage early in this course. Come to the labs, ask me questions early, get on the discourse forum, and make sure that you're doing everything in our assessments schedule on time and early. Build things that you want to, not because you have to. Nothing in this course is like sort of a hard and fast rule almost. There's a lot of things which are, even though we have specifications, there's a lot of scope for exploration. I'd rather see exploration in the assignments rather than quite boring submissions that stick to the specifications, although you do have to make sure you understand the specifications. And make sure you attend your labs, even if you don't mind losing the marks for your labs. I know some people will make that choice. If you don't attend your labs and then ask me to answer questions over email, I'm probably going to say, well, that's a question your tutors would have helped you with in your lab. That's what they're there for. That's what your labs are there for. There's great help and discussions going on for how to sign up for labs, but also, which is really, really good to see. We have a website in computer science called Streams, which is our lab sign-up system. What you should do right now is go to the streams and make sure you can log in. And if you can, then at 2 p.m. today, you'll find that the link for joining a Comp 1720 lab will magically become active. I'm not going to enable it until that time, sometime after this lecture finishes. I have to do it at a time when I'm free because things get a bit crazy sometimes when lab signups happen. So I want to be free to answer questions on the team or the discourse. All right, we are about halfway through. So if you've got any questions, I know there's questions coming in, but chuck them in the chat. I'm just going to go to my, have a little break for a second and sip some water. Oh no, the on-campus drop-in session clashes with something for somebody. Oh, I'm sorry about that. We just had to choose a few times for that drop-in session that made sense for the tutors. It's not the only way to get help. If you need help on the forum, you can always ask questions, even quite detailed questions, and people will be quite keen to help you, including me. I'm not seeing any questions jumping in. Alrighty. We're going to more of the practical part of the lecture, but first a little thought about art and code just to get your brains moving. This is a quote from Peter Lee, head of Microsoft Research. If you look around the world and where technological surprises are happening, one place is in the art world to create new experiences. So this is perhaps something to think about, particularly if you're more of a technology or engineering student. Why would you study art? And what artists know, what sort of tech-focused artists know, is that in order to create really interesting art, you have to push technologies, particularly interface technologies, screens, input devices, all of these things. There's a lot of innovation that happens in computing interfaces that happens from the art world. You can explore some really exciting concepts. So it's something to think about, that these fields are not like as completely isolated as you might think. A lot of interesting work in the art world feeds into concepts in the tech world and vice versa. People invent some new tech, wonder what to do with it, and an artist will have their hand up saying, I know what to do with it. The big picture of this course is as follows, that it's not either art and technology, but it's both art and technology. And if you want to do well in Comp 1720, then you have to engage with both aspects of this course. It's not a situation where at this first lecture you should be thinking, oh, I'm just a tech student, I don't need to worry about the art too much, or I'm just an artist, I don't need to worry about the tech, I'll just learn the bare minimum. You can really explore both sides in this course and extend yourself and perhaps surprise yourself about what you discover. A short list of what we cover in this course, just sort of broadly. We cover a lot of visuals. It's a course that's really spends a lot of time teaching you how to essentially draw with your computer, draw with computer programming. We will also cover a little bit about sound, how you can make sounds with your computer. Not to the same extent as a full course on sound and music computing, but a little bit. And then we'll also talk about interactivity, interactions. So maybe the first starting points of what we call in CS human-computer interaction. That's a research field. And within the course, we will have time to look into these concepts and apply them into our artworks. We'll also spend a lot of time learning the tools, which is worth the effort. Learning about GitLab, learning about an editor called VS Code, learning about JavaScript. These are all tools that enable us to make interactive computer artworks. We'll also talk about how to conceptualize an artwork, the process by which you can take an idea and turn it into something which is compelling and interesting to an audience. What won't we cover in this course? Well, we won't cover all of the rest of web and JavaScript technology, all this list of keywords here. This is not a course in web development. It's not a course in front-end web. We have other courses for that. It's not really a course in JavaScript, although we use JavaScript. We apply JavaScript, but we don't learn all the ins and outs of it. So there's a lot of things here which many folks find really interesting. I find them interesting as well, but we just don't talk about them in the course because we want to focus on art and interaction computing, not these other parts of web technologies. You're welcome to read around on your own and even apply some of these things in this course, but it's not going to be covered directly. Someone's asked a good question. Can I finish the lab works in advance and just get marks during the labs? Well, no, you can't, because part of your in-lab, you'll get a mark for the pre-lab work. That's due before the lab, but the in-lab tasks involve collaboration and staying there and being present in the labs. So if you're not present in the labs, or you're just present for like 5 minutes at the beginning, unfortunately, no, you're not going to get a mark for those in-lab tasks. And I hear you, if you have a job, you're an intern, or you find it hard to attend the labs, I hear that is going to be difficult for you, but this is a university course. We expect people to attend. I'm very flexible about the lectures, but I'm not that flexible about the labs, because if people don't show up to labs, they tend not to learn. So it's tough. Someone's mentioning Runway ML already, which is a bit of a leap. We might talk about that in week 12. Here's a story for this week. Sometimes we have in these lectures a little bit of a story or an analogy. This is the code part of the lecture, basically. So if you don't know anything about code, switch your mind on now, because this is where we're going to start revealing the deep secrets of how to program computers. They're not that deep. The story is painting like a 5-year-old. I don't know if you've ever, tried to get a kid to do something. I've had experience teaching small kids, different things, teaching them drums actually, but if you're trying to get a kid to do something, you might give them a sort of broad instruction like, okay, please go and draw a picture of a house. And the first thing they'll do is be like, well, I don't know how to do that. You're going to have to give me more specific instructions. I'm not drawing a house. And if you want them to draw a house that sort of matches your vision, because they're just a kid, they don't have the context of maybe what you mean when you're giving them this sort of broad instruction, you might say, okay, well, to draw a house in the way that I want you to do it, first you're going to have to make a square, and then we'll draw a triangle on top of it to make the lid. I keep thinking lid, the roof of the house. Here we go, I can draw it on the screen with my little tablet. First time for using the tablet in 1720 this year. Okay, first make your square to draw the house. Cool. Here's the roof of the house, is going to be a triangle. Okay, now we need a door and some windows, so the door is going to be another square in the middle that touches the bottom of the square. And there'll be two windows, there'll be squares either side of the door. Okay, and then the window frames are going to be a line, two lines crossed in the middle of each of those windows, and then for that door handle, we're going to have a little circle, and there's a house. So you can sort of make a list of specific instructions, and if you did that, well, a 5-year-old would probably produce something which is what you've specified. So the point of giving you this little story, this little analogy, is that drawing with a computer is a lot like painting like a 5-year-old. You have to give very specific instructions of each part of the story that you want to know about. I'll just answer someone on Teams. Sorry, MS Stream is not working very well today. It's working on Twitch and YouTube if you have access to those. We'll be on Echo 360 later. Okay, so when you want to make art with your computer, you do have to paint like teach a 5-year-old to paint. Give very, very specific instructions that precisely outline everything you want to do. There's no command line of code in our programming languages we're going to try called draw a house. You have to say draw a square and then draw a triangle, then draw all of the lines and other squares that go inside it. Oops. So here's our code theory. Before we begin, a very quick glossary of some important terms. This is something you might want to come back to if you're new to coding, these special words, but they're important for this course. The first special word you might have seen before on the website is p5.js. Well, that's a very weird word, isn't it? But what it is a system for allowing us to make art with a computer in a very accessible way. It's what we call a library, which is a very confusing thing to say, but it's a system that lets us make interactive code art in a programming language called JavaScript. Well, okay, but what's JavaScript? Well, JavaScript's a programming language, and it actually runs in any web browser. So all of your Chrome, Firefox, even Internet Explorer, Safari, web browsers on your phone or your tablet, whenever a program runs, which is any website really these days, it will be written in a language called JavaScript, or almost always. And that code runs on your computer. It runs within the web browser. So P5.js is something on top of JavaScript, which gives us some really nice, convenient ways to make artworks with this JavaScript programming language. But when we're programming P5.js, the language we're speaking is JavaScript. So, another word, a sketch. Well, you know what a sketch is with a pen and paper, right? It's a sort of quick drawing. And in P5, we use this language to refer to an artwork that we can view and interact with in P5.js, in this P5 system. Pritam has got an interesting question I'll get to in a minute. But every time you do an assignment or a lab, you'll be making a P5.js sketch. The web browser, a browser is your web browser. It could be Firefox, Chrome, IE. I tend to use Firefox in my lectures and to test things, so using Firefox is probably a good bet. An editor. What's an editor? It sounds like someone who goes and looks at your essays in Microsoft Word and gives you feedback. In the context of programming, there will be, still going, maybe someone else can help you with the link. I might just take a little break after this slide to make sure I help everyone find the lecture. In an editor, in the context of computer science, is a program that lets you edit code. So like Microsoft Word is a document editor, we use a program called VS Code, which is a program code editor. Another editor which we use is one that actually lives inside a web browser, and I use this a lot in lectures, and I will call it the P5JS online editor. Now, someone asked a good question, which is, why use JavaScript and not any other programming language? Well, in fact, earlier versions of this course used Java and a drawing framework, interactive code art framework called processing. And then after some time, processing was going along with Java, and then some bright sparks had this idea that, well, we could make a similar system in JavaScript, and that means that you don't even need to have a computer to do it. You could either do it on a tablet or a phone. You can do coding in the browser, and all of your code will just run within a web browser. So it's really kind of neat and exciting to be able to make interactive works of art that you can then share to the whole world through a website. And that's one of the reasons we use JavaScript. Another reason is it's quite a sort of easy to get started language. It's designed to be easy to start with. And also the P5.js framework is just super duper convenient. And that makes a big difference to a beginner to have a convenient place to get started. Editor is similar to Notepad for editing coding, but you'll find that VS Code has a lot more functionality than Notepad. The question is, does your sketches automatically get launched? They don't get automatically launched. I'll show you how it works in a minute, okay? So just have a little bit of patience on that question. We'll get to it. I'm just going to make sure I get the link right for YouTube, and I'll paste it in. Oh, someone already did it for me. Thanks, Sneha. That's handy. VS Code is not a very large program. It's a very small program. You need to install VS Code for week 1. It's part of your week 1 lab tasks. So, you'll find out yourself. VS Code is one that's replacing brackets. I don't even know what brackets is, so that's a very good question. An editor, is this the same as an IDE, or are they different things? This is getting into a sort of deeper computer science philosophical question. IDE stands for Integrated Development Environment. I think an editor is a bit more like a smaller program than an IDE, and VS Code is probably a smaller than IDEs. Editors work with like all kinds of programming languages, and IDEs tend to be specific for one. So I don't know. Philosophical question, ask it on the forum. P5.js versus JS. Probably there's some folks out there who are like, what is this JS P5 thing? I don't understand the difference. Well, P5 is on top of JavaScript. JavaScript is the language, and P5 is sort of the list of acceptable sentences. It's a higher level concept to have a library of additional functionality put on top of a language. You might hear me say P5, P5.js, P5JS. All of these things mean the same thing. They're not anything different. One thing which is really important and useful is the P5JS reference. This is one of your most important resources during this course. I'll talk about it as just the reference. I mean this website, p5js.org reference, which is a list of all the things you can do in P5JS. Seriously, go to the reference and have a look at it. That's your admin task. A few key concepts for you for today before we do a demo. Painting or drawing in P5. Now, a P5 sketch is a digital canvas, right? So I told you a sketch is like this piece of paper you're drawing on it, doing a quick drawing. So in P5 you can imagine that you've got a digital canvas for drawing lines, shapes, or other things. Circles, rectangles, splashing paint on it. Anything you can draw, you can do in P5 on this digital canvas. This is what we're going to get started doing today, drawing lines, shapes, and other things in P5. Now, one thing to remember, which is really important concept, the order matters. Now, if you were painting a fence and you wanted to have a red fence and you painted it all red and then you got out some white paint and painted it white and you turned around and looked at your fence, you would say, my fence is not red, it is white. That's because you painted it red first, but then you painted over it with white. If you painted it white first and then painted it red, you will obviously get a red fence. Now this seems extremely obvious and clear when I say it like that. If you're just painting a fence, the color that you paint on last is the color of the fence. But sometimes when people are writing computer programs, they get a bit confused about which thing happens last, which thing happens first, which thing happens last. So we will talk about this in more detail, but just like painting a fence, if you have to put the color on last that you want to actually see. So you can end up with objects or parts of your drawing that are in the wrong order in your code. You've gotten confused. It's easy to get confused when programming. That's okay, I do too. But sometimes if your drawing isn't looking the way you want, it's because the order has gotten jumbled up. Another important concept, the grid. When we're telling a 5-year-old how to draw a house, we probably would just point to a bit of the page where they're supposed to draw the house. But you can't point on your computer. We have to communicate where things should be painted to P5. And the way we communicate is with numbers. And this is where someone's recommending W3 schools. Don't recommend W3 schools, just do the course. This is where the course gets a little bit mathematical. We do deal a lot with numbers for putting objects on the page. And I know there are folks out there who maybe say, oh, I'm not good at maths, this is not going to work for me. Well, I hope that you persevere, because when you think about numbers in a different way through coding, you tend to understand them a bit more differently than you might have in maths class. My friend is not completely enrolled in the course. No, you can't get into the team group first, sorry. You have to wait until you're fully enrolled to get into the team. So when we're looking at the placement of objects in P5, we're always communicating that through numbers. And one little thing is a bit different in our sort of numbering system. You probably have done some maths in high school where you did have, like this Cartesian plane, 2D plane, where as you go to the right, that would be plus numbers, and as you go up, that would be plus numbers. So if it gave you a location like 2, 2, that's going to be this location. Whoops. When we do this on the computer, the going right as we go up is the same, but in the Y direction, going up, down, down is actually positive numbers. So 2, 2 here is to go out 2 and down 2, and that one's 2, 2. That can be a little bit confusing to start with, but it's just a sort of convention about computer graphics. Computer graphics always starts in the top left-hand corner. Let me see if I get this right. Here. That's the top left-hand corner of my little area. It goes out and then down. So the X direction is going out to the right and the Y direction is going down. A slight change in thinking, but that should be okay. Yeah, both x and y have positive numbers. I suppose you can use negative numbers, but this is like the left hand, that's the edge of the screen, right? This is your computer monitor or your window. And if you do -1, you're going to be off the window or off the screen, and you won't be able to see something you draw there. So we do tend to only have positive numbers for our locations in computer graphics, and they go to the right, to the right, and then down. Just trying to get the orientation right for you folks out there in computer land. I'll show more demos of this in a minute, but I always pressed the wrong key. The grid, it's really important. All of your drawings will go on this grid of numbers, which I guess correspond in some sense to pixels on your screen, individual pixels, but often they're scaled a bit because your screen is very high resolution these days. So we represent all of the 2D positions that we locate objects on our canvas in the grid with numbers. This is a theme. Everything's going to be numbers. It's just like the grid of a city or graph paper from high school. The units of location are called pixels, or px for short. Pixel stands for picture element. It's like the smallest element of your image is 1 pixel, which can be exactly 1 color. Next thing, we've got locations. This is helping the 5-year-old draw a house. We've got the locations, and now we want to do some colors. What color should the 5-year-old choose? Well, I suppose we could just tell a 5-year-old, get the green crayon. And sometimes we can actually do the same thing in P5. You can just say, get the green color. But there's another way which is probably going to be more useful as we go along, which is specifying exactly the kind of color with, you guessed it, numbers. So we can specify the different components of a color, the different amount of reds, the amount of blue, the amount of green, to mix together to make a color with numbers. And the numbers often go from 0 to 255. That's 255 is a weird number, isn't it? Why do we use 255? Someone yell it out in the forum, a computing student. I'll sip my water. Why do we use 255? Maybe I lost all of my people watching in real time. There's definitely 60 people watching on YouTube. Good on you for watching on YouTube. Thanks, folks. We have an answer from Gene. 8 bits, that's right. In computing, we often have a very important, someone saying 1 bit for the buffering file. Yeah, okay. I'm not going to talk about the buffering. We're talking about the representation at the user end. In computing, we often deal with powers of 2. So a 1-bit number can either be 0 or 1. A 2-bit number can be 0, 1, or 2. That's 2 to the power of 1. A 3-bit number can get up to 8, or get up to 4, sorry. 4-bit number can get up to 8. And an 8-bit number can get up to 255. So it's to the power of 8. So it's an important number in computing. We often see 255 as a maximum. You might say, oh, but to the power of 8 is 256. Well, yeah, but we need to have 0 there as well. So it starts at 0. There's 256 options. And the lowest one is 0, and the highest one is 255. I think I made a mistake with something I just said, but yeah. And you combine these numbers in the typical way. Red and green is yellow, red and blue is purple, etc. You can also make colors transparent. And you can use different color modes. We'll talk about that a bit later, and we'll do a deep dive on color, but we might talk a little bit about transparency because it's fun, but the main thing is, if you want red, it's 255 for the red part, then 0 for the green, and 0 for blue. and you can generate other colors. You can go to websites that help you find the codes for different colors, the particular numbers to use, or you can experiment with them in your, on your P5 sketch. Now, you might be thinking, okay, so far I get this. We've got the grid, we've got numbers there, we've got colors, we've got numbers, but how do I make it do the painting? Why do I make it do painting? Someone's asked a question, what's alpha? Alpha is transparency. So if a color on a computer has a low alpha, that means that it's almost transparent. You can see right through it. So we can have colors that overlay each other with transparency. I'll show you in practice in a bit. How do you know what kind of words you can say to P5? Well, the easy answer is go to the reference. The reference has all the different instructions you can say to P5. But what do we call these instructions? Whoops. We call them functions, which is a bit weird sometimes. We'll talk a lot about functions in later weeks, but each of these special instructions you can give the computer, you have to look in the reference to see what they are and how you can use them, because they'll have different kinds of, different information you can give them. And just as a warning, if you use Australian spelling, in P5 there's no U in colour. So if you use Australian colours, it will not work. Sorry. Let's go to the reference and we'll have a look at one right now. Here's the reference. Now I want to make a circle, and I happen to know a bit about P5. So someone's asked me a kind of deep question. If you're writing an essay or report in ANU, should I use US spelling or UK spelling? This is an Australian university, you should use Australian spelling. P5 reference, ellipse. It says a method. Well, I'm just going to say this is an instruction we can give P5. And here's what it looks like. Here's one of these instructions. Ellipse means make a circle. I happen to know that that's the way to make circles in P5. And when you give this instruction, it's followed with these little brackets and then 4 numbers, 56, 46, 55, 55. Well, what does that mean? What are these 4 numbers? Well, we can go down here and have a look at what we call the syntax, and it explains what these numbers are. In programming, we call the little detailed instructions that you give to a big instruction like ellipse, we call them parameters. So there's ellipse is the instruction, these numbers are the parameters. We've got 4 parameters, and they stand for the x coordinate of the center of the ellipse on the grid, and the y coordinate of the center of the ellipse on the grid. That's the first 2, x and y. Then the width of the ellipse in pixels, then the height of the ellipse in pixels. And you can see that one says optional. So if you only give it 3 parameters, it probably assumes it's a circle that has the same width and height. There's a bunch of other stuff, but we don't have to worry too much. Sometimes when you're learning programming, one of the skills to learn is how far to read in the documentation and where to stop. I would say read far enough to do what you want to do, and then not read any more details, because usually there can be details all the way down for many specific situations, and the most common situations are met by the basic information that you're getting. All right. So I'm just going to go back to the slides for a little bit, and then we will do some demos. Here's 2 functions, the ellipse and fill functions, or instructions. So these instructions tell P5.js what to do, what function to perform. And in P5.js, many of these functions are about drawing on the canvas, different ways to draw things. Sorry, I just touched my mic, it would have gone ka-chunk in your headphones. Many apologies. And we talked about, I dropped a word in there which you may not have understood, which was syntax. The syntax of a programming language is the order of which you put instructions, other symbols and numbers in order to make something understandable to that programming language. Oh, a very good question from Songshin. We'll talk about that in a minute. I'm going to show you a demo, but I just want to make sure that this terminology is okay. The syntax is the way that a programming language expects to get an order of instructions, symbols, parameters, and other information. Just like the syntax of a language, a spoken language. So here we've got a function called fill, and the fill function is going to tell P5 what color we want to use to draw something, to draw the inside of an object, the fill color. We say the fill function takes 3 parameters, and that might sound very confusing, but what that means is that after typing fill, the word, you then have to put a parenthesis, and then you will put 3 numbers with 2 commas in between those 3 numbers, then another parenthesis to close it, and then at the end of the line you put a semicolon to say, tell the computer that you got to the end of the line. You don't have any more detail for this instruction. Now, the important thing here is that when you have a starting parenthesis there, you have to have a closing one. And if the fill function expects 3 parameters, you might not be able to give it 2 or 6 or 10 and have it work. You might. Sometimes there are functions which have different numbers of parameters you can give them. And fill's one of those actually, but in this case we'll assume we really just need to have 3 parameters for fill. Now, the good thing here is that these parameters mean that our functions are reusable. So in computer programming, our fill function can do a lot of different stuff. It can fill objects with lots of different colors. And that seems sort of obvious, but it's actually, within computer programming, it's something which is not completely obvious, that one line of code should be able to do lots of different things depending on what numbers you put in there. But that's how it works in JavaScript. Yeah, people are asking some questions here which are getting a little bit in depth. We might have to discuss these ones later. I will show how this fill and ellipse works in practice in a minute. Functions are what to do, what P5 is supposed to do, and parameters are how to do it. What colors to use, where to put the circle, these kind of ideas. Functions are what to do, and parameters are how to do it. I'm going to show you the demo now, and then we'll show you some more slides maybe. So I'm actually going to get into VS Code. And I've got, this is actually the Lab 1 template. And I'm going to type in some functions. So we already know about this ellipse function, right? We could use some of the numbers that they had, similar to what they had in that example online. 50, 85, 20, 20. I'll put a semicolon at the end. Now I've typed in my code. How do I make my, how do I see my sketch? That's Andrew, wait, VS Code runs on Chrome. It's a separate executable. It's not to do with Chrome. If we want to see our sketch, and assuming you followed through with the Lab 1 instructions, you'll have added the Comp 1720 extension pack to VS Code, which gives you some extra functionality. And what you need is to click this button that says Go Live. If you haven't installed the Comp 1720 extensions, that won't work. So when I click Go Live, I get my circle. Wow, we just drew a circle. And it's showing in my web browser. You can see this is Firefox that I was using to give my lecture. Well, I don't like that circle. I might want to make it bigger. So I'm using the wrong keyboard. How am I going to make it bigger? I've got 2 computers here so I can see what's going on while giving the lecture. I'm going to make it like at least 3 times the size, or 300 by 250. So it's not going to be a circle anymore, maybe a bit smaller on that dimension. It's going to be a weird oval. How do I display it now? Well, I'm already running my live server to show the sketch. So all I have to do is save this file and it updates. There it is. You can see that I now have the center of the circle is about there. A bumping circle. We will be doing circles that bump into each other in week 10, I think. Maybe earlier. The center of my circle is here, and it's very close to the edge, so when P5 draws it, some of the circle goes off the page. So I might move it more into the center of my page. Let's do an experiment. We'll do 500 pixels in and then 10 pixels down and see where it shows up. Wow, so it's kind of showed up where I pointed to. 500 pixels in, 10 pixels down, that's the center. I want it to come maybe 600 pixels down. Okay, now it's gone in that far and down a little bit further. So now we can see our circle. So far we've used the ellipse function and we've been playing around with the parameters to make it work. What about this 3-parameter version? I mentioned that before. Can we take away one of the parameters? Sure can. And we get a circle there. A perfect circle. You can also just write that parameter twice. Remember that the syntax here is that that's the distance in for the center of the circle. That's the distance down for the center of the ellipse. This is the width and this is the height. So we still get the same circle. Well, this is all very fun. We can draw circles. I can draw 2 circles, in fact. I'm going to do another one. 300, 350, and it's going to be a little smaller circle, 285, and maybe a slightly wonky circle, not a perfect circle, a poorly drawn one. I've got 2 circles. You can see one of my lines of code is drawn above the other. When the computer is running this code, your web browser is running the JavaScript code, it does this line first and this line second. So this is the order of operations I talked about. It seems easy and obvious that would be what happens, but things get a little bit more complicated sometimes, as we'll see over the next few weeks. I'll make a 3rd circle, or make a tiny little one. Maybe one that overlaps with these ones. It's going to be like 450, 500, and it might be a little bigger than the previous one, but a wonky shape. We'll see if it overlaps. Whoops. You see there, I did something in the wrong place in VS Code. I put my semicolon before I had my parenthesis, and my VS Code knows that that's wrong, and it's telling me about it. I wonder what happens if I save this. Should we see what happens? Absolutely nothing happens because the code is incorrect. We have to be exactly right when we're putting the code into the computer. And the editors tend to do a lot of work to try to help you get things right, particularly if they're minor errors like that. This semicolon should be on the outside of the parenthesis. Then when I save it, it will work. But if you're drawing something and you find, wait a minute, nothing works, you might have to think about exactly what it is about your code which is confusing the computer. It's not because your program's wrong, it's just because the computer is confused by your instructions. So I got my 3 shapes here. I think at this point I'd like to add some color. So I told you about the fill command. Whoops, file list, no. I think my editor is being a bit too, I don't know what's going on there. I might have to remove some special function, which is trying to be too clever by half. Well, you see, this circle in the middle covered the other drawings because, in fact, it seemed like they were just drawing the outline of a circle, but it was actually drawing the outline and then coloring it in with the color white. So if I make it red, 25500, you remember I said that fill has 3 parameters. One is 255, one is red, the amount of green, the amount of blue in the color. And what this command is going to do is basically tell process P5 to fill everything with red color from now on. Pick up the red paintbrush and start painting with it. And then everything else that you do after that will be filled in with red. So now I've got 3 circles and they're all red. I haven't just made the first circle red, I've made them all red. And you can see that this last one's overlapped them and colored them in red. If I want to make them different colors, well, I'm going to have to put in a different command each time. I might make this one green. And this one blue. Whoops, that's wrong. Okay, so now I've got a green circle here, a blue circle, and a red circle. And you can see the blue circle is overlapping those other circles. So it's painted on the top. The order matters in P5. You need to make sure you get the order of your lines of code correct in order for you to get a result that you like. Ooh, someone's asked a very good question. Do we use a different command to color the background? We absolutely do. And I think the command might actually be background, but let's just check it. We're in the reference. Background. There you go. A good question for the reference. And background, you can see it's one of these tricky ones, tricky instructions that can take lots of different numbers of parameters. So in fact, if you want a grayscale background, just shades of gray in between black and white, we can just use one number. So maybe we'll use like 35. That'll be a kind of gray background. I'll go back to my sketch. That's a sort of dark gray background. I want a light gray background. I'll get closer to 255, 200, light gray. This is a just delightfully 90s kind of color scheme we've got happening right now. It's very Windows 3.11. Maybe that should be a theme. I had like the synthwave theme going on in the intro video. Maybe we should have a 3.11 Windows 90s era theme. Yeah, so we've got we're coloring in our background. We're coloring in one circle and changing our paintbrush to another circle. You can see I've got some empty lines here. I don't need those empty lines. They're just there for my own benefit. Oh, Ali's got a very interesting question here. What if we put the background somewhere else? What if I put it after the first ellipse? What happens now? Our first circle will disappear. We've erased it from time. If I put the background at the end, all of my circles disappear. So what's happening here is I've gotten out the red paintbrush, draw a circle, get out the green paintbrush, draw another circle, get out the blue paintbrush, draw a third circle, and then get out a gray paintbrush and just color all over them. And I've got nothing. So you can see how if you had a very long program and you accidentally had a background command right at the end, you might say like, where's my circles gone? Andrew's got a question about, does it run on Chrome? Do you mean, does it work on Chrome OS? So, no, I don't think so. You can use now. I'll put my background drawing right at the back again. Yep, the logic of background is to color everything in your web page. So I've got a web page here, and it's colored the whole of that background with gray. Now, if I want to use a color that's not just a grayscale color, I can use 3 numbers as well. What about something a bit different? This kind of dull, greeny, greyish colour. I might just change that. Nice purple colour. I might leave that. I like that one. There's messages all over the place here. How to put multicolour or blending multicolours. How to blend colours. We will go into... You can use background on the setup. We're not going to talk about setup and draw today. We'll talk about that another time. So we'll just leave that one for a later lecture. We've done some drawing of backgrounds. We've experimented with fill and ellipse. Now you might notice, I'll just comment out the background. If you put, here's a good trick in JavaScript, if you put 2 forward slashes before a line, that means that it's not going to pay attention to that line. So if you want to try removing something without deleting it, you can just put it in a comment like that. There's actually a good shortcut. It would be Control / comment, uncomment, comment, uncomment. Programmers do this all the time. Just comment some stuff out is what we say. That's the terminology. We'd comment that out and see if it works. So I'll comment this out. We've got a white background. And you can see I've got a little black line around all my colors. I'd really like that to go away. So I'm going to introduce you to another instruction, which is called stroke. Why would it do this? I've got something wrong with my VS Code. I'm going to have to do lab 1 and convince it not to do that. 255, I'm going to use a red stroke. And this is the color that it will use to color in the edge of the shapes. So I'm using the same color as the fill color. And when I press go, oh, my strokes sort of, they look like they're disappeared, but they're still there. They're just colored the same color as the fill color. If anyone knows what Microsoft Paint is, this will sort of, oh, do you have fill colors and stroke colors in MS Paint? I'm not sure. Maybe you do, maybe you don't. But it feels familiar for me from like old school drawing programs to have a stroke color and a fill color. Okay, back to our lecture for a little bit. I did show you a problem before when you got something wrong in your code, and it was a matter of knowing what happens when things are going wrong. We'll talk about this in a bit more detail, but you can actually have a look inside your web browser. There's a special screen you can access to tell you what's going wrong with a website when it's broken. And I'm on Firefox, so I need to press Control-Shift-I to access that part of the system. I'm going to make the same mistake I made before. And I get nothing. Now I'm going to get that special window open called the console, which gives you information about what's happened. I press Control-Shift-I, and now I'm going to press console. And it says, uncaught syntax error missing parentheses after argument list. I know it might seem scary. Oh, this is very small for you, probably, but it might seem like the red exclamation mark and the red text is very scary, like the computer's angry with you. It's actually not angry with you. It's more angry with itself that it can't sort this out. It can only see a semicolon and it can't see a parenthesis that it's missing. And it will actually tell you what line of code to look at. So you've got sketch.js. This is the file we're looking at. And it says line 17. So there's line 17. And there's the problem. And we can solve this problem. We're drawing our circles and our problems have gone away. Well, there's some other problems there which we're not going to deal with right now, but using the console is a good hack when you're doing a complicated assignment and you're trying to get stuff to work and it's not working for some reason. You can usually get some hints from the console about what you need to fix in your code. Okay. We will come back to the debugging process a bit later. So this is the workflow which we've been using so far. I've downloaded Lab 1. I've opened my code file in VS Code. That's sketch.js. I've clicked Go Live down here to run the live web server to look at the code. And then I've pointed my browser, or it's pointed itself automatically to this special address. It looks sort of like a phone number and not an address. It's actually, this is the address of your own computer. It's like saying, look at myself. And then this is another number to represent the particular server which is speaking here. So you can see here that 55,500 matches 5,500 down here, which sort of makes sense. This is the number that this server delivering this website is talking on. It wants to talk on number 5,500, port 5500, and then the web browser is going to look on that specific port. If you've never done development of web things on your own computer, you probably will have never seen that little colon and a number before after a website address, but it's the kind of thing that you do all the time when you're doing development on your own system. Okay. And then every time, as you saw, every time I pressed Control S and saved my sketch, it was updated in the website. In a minute, or a bit later in the lecture, I'll show you another demo using the p5.js web editor, which is where I tend to do demos in lectures because I'm already in a web browser. This is easy enough, but it's the same thing, right? I've got this code here. I can make an ellipse, 50, 200, 200. There's my ellipse. And there's my background is 220. This sketch is a bit smaller. It's been set to be a little square rather than a full window. But we can change that. Okay, so this is why I do suggest you do the Lab 1 content this week. Do it early so you get the hang of this. If you have a look at the Labs website, there's information about our drop-in labs somewhere. Oh, maybe it's on the Lab 1 site. Here's the two options for the drop-in labs. They're there so that you can, if you need any help, you've already attempted Lab 1 in your own time. You need help, you've got questions, you can't figure it out, come to the lab, either in person or on Teams, and we will help you with it. The tutors will be there to help you. All right, a bit of praxis. Why don't we make some art? What kind of art can we make with shapes and colors? Well, in some ways, anything, but an interesting option might be to try to make a print in the style of Pierre Mondrian. So this guy Mondrian was a Dutch artist who was very famous in the early 20th century for these compositions in shapes and colors. And he tended just to use like very basic bright colors and black and white to create these really interesting works. So we might try one of those in a moment. I'm just going to go through some of the extra slides. Oh, we'll try one here. Let's make our Mondrian print. So I'm going to make a bit of a bigger canvas. Maybe it's going to be 700 wide. And it's sort of going to be a portrait style canvas, so maybe 1,000 high. Is that going to work? Oops. That's too far down. I don't want it to fit on the screen, so I'm just going to fiddle about with it for a minute. 600 by 800. Oh, that's right. Now it fits on the screen. Cool. And in the style of Mondrian, we're going to be using some squares. I haven't told you how to make a square yet. So if I search for square here, what do I get? I do get a method that says square. But some of Mondrian's artworks are not squares. They're actually rectangles, aren't they? So maybe I need to look for rectangle as well. Rectangle doesn't give anything, but just rect. That suggests this message, this method, this instruction. And it looks very similar to ellipse, as we were playing with before. So we've got 30, 20, 55, 55, 4 different parameters. And what we could look down here and look at the parameters. The first two are the x-coordinates of the rectangle. Then there's the width and the height. And I know that with the ellipses, you gave the x-coordinate of the middle, but I think with rectangles, you give the x-coordinate of the top left-hand corner. Let's just try that. We'll make a rect instead. And it should show in a different place. Yeah, see? That was the center of the circle. And now it's the top left-hand corner of my square. So if I want this to be in the very top left-hand corner, it's going to have to be there. So we'll make a really simple one. I'm going to start with a nice red square. And in fact, I don't want that little black line. I'm going to tell you another function to get rid of it. I'm going to say no stroke. No stroke is an instruction function. It takes no parameters. All it does is tell P5, just don't draw the strokes. What? I was doing background. I want to do fill. First mistake. No. There's my square, and I really want a white background, so I'm going to make that. Background 255. We'll make the white, or maybe a little bit gray, like it's sort of a slightly paintish kind of color. Yeah, that's pretty good. And then I might get a blue rectangle. I'll make this one a bit more of a even size. I keep pressing Control S as if I'm in VS Code, but I'm not. Let's make a blue one. RGB. I'm going to start it. I have to work this out now. So I want maybe a rectangle like here. So I want to start at 200, have a little white stripe. So I might go to 210 for the starting point. And the Y starting point is going to be at the top of the screen. That's still 0. And I want it to be for the rest of the screen. So my width was 600. 600 minus 210 is going to be what? 390. This is where the maths comes in, right? You have to do some little quick calculations in your head to work out how wide things should be to fill in the screen exactly if you want to do that. And then maybe I want it to be double the height. Nice blue square. I actually want it to be a bit further down, 550. Okay. And then maybe like yellow one. How am I going to get yellow? Does anyone know? Don't have any more. How can we fade in color? A very good question from Pratima there. I might get to that in a minute. How do I get a yellow color? Ooh, someone's got the answer. We have to mix two different shades together. We can't just use red, green, or blue. We've got to mix two different colors. So if I want a yellow square, I should mix red and green together, and then I'll get yellow. Okay. Yep, that's great. Thanks, guys. Thanks, folks. I might move this in. It's going to start at the left-hand side, is it? I want to be leaving the little stripe there. Maybe I want to start in like 40. Come down to 10, similarly to leave that stripe, and then I want to come in the rest of the length of the square. So the square is 200 pixels in width, minus 40. We're going to get 160 left, and then I want to have a height of 320. There's my yellow square. That's a pretty gross yellow, really. Sorry, I'm being a bit snobbish about it. we just take the edge off it a bit? Yeah, I still don't like it that much. Someone else will tell me how to make a nicer yellow. Anyway, do you think this would be up to P.A. Mondrian's standards? Probably not, but it's the best I can do in 5 minutes. Was there any color code list? Well, someone's asked if there's a list of different colors. Well, there's some colors, I think, which are in a list. If we go to color, that's not really what I meant. These things can be a little bit tricky to find the right place. There's some colors that you can just give by name. You can just say magenta and it will give you magenta. Basic colors will have that, will probably work. I don't know where there's a list. Someone else can find it in the reference for me. Show me the list of all the possible color names. But also, if you want to find any color, you can probably just Google a color picker or find one. And then you can scroll through all the different colors to find the one you want. Ooh, there's a good website, HTML Colors. That's going to give you little color schemes. We'll talk more about different ways to select colors because it's quite fun to go through these different options, particularly the hue, saturation, value ways of choosing colors rather than RGB. So there's that bright yellow. Oh, maybe I want more like that yellow. I'll copy that one and use that. So thank you, Pratima. We've got a much better yellow now, I think. Yeah, that's a bit more Mondrian. Yeah. Yep. There was a good question about making colors more transparent or fading them in. Transparent means you can see through them. So if I make another big square in the middle, this is going to ruin my print, but suppose I've got some transparent material like cellophane or semi-transparent plastic. I can make another color, which will be, maybe I'll make it kind of grayish. 25, 25, 25. It'll be very dark gray. And I draw this right in the center of the screen. A big square. It's going to ruin my print. Oh no, I've got a big black square. I'll move it across a bit to the left. You can just also just adjust your numbers until you get where you want it. Big black square. Now I want this black square to be semi-transparent. So actually I can add an extra number here. I'm going to add 0.5, which will make it sort of 50% transparent. Oh, it didn't work. Maybe that made it completely transparent. Maybe I have to say it half of 255, which would be about 127. Am I doing the right thing here? There it is. Semi-transparent. If I want to make it really transparent, I can make that fourth parameter smaller. And if I want to make it only a bit transparent, I can make it bigger. So there's my new P.A. Mondrian print. I'm just going to finish off this lecture. We've got a few more slides. The moral of this story today was that we can make the computer paint, but you have to give it very, very specific instructions, very specific. You can see we had to get everything in the right order, get those parameters exactly right to put things in the right places. And this is some of the skills you'll need to learn as we're going through this course, how to combine your idea for an artwork with the requirements of P5 for everything to be so specific. One problem with computers is that you can't do any vague instructions. The computer is even more obedient than a child who will at least make an attempt at something. Computers won't even try. If you haven't expressed yourself clearly, they will just give up, and that's where we have to do debugging to figure out what's going wrong. There's a lot of programming to learn in this course, and sometimes students get a bit frustrated in the first couple of weeks because we're doing a lot of programming. The reality here is that to program you need to practice, and I need to introduce the concepts to you in order to do them. It's only week 1, so don't panic about that, but a lot of time over the next 6 weeks is about building the code concepts. Then after the mid-semester break, we're really focusing on developing your art making concepts, although you will be making artworks at every stage. It's just we tend to introduce stuff before the holidays, the break, and then cement it in, develop it afterwards. A few dangers, not as dangerous as sitting on that rock. Someone might say, the code stuff is too easy, see you later in week 10. Ooh, very dangerous, because you'll miss all of the development stuff earlier than that. And you probably don't know some details about the code stuff. Even if you think you do, you might learn something along the way. The code stuff is too hard, I'm out. People say this a lot, and my job is to make sure that those who are feeling scared of the code stuff feel relaxed, because we are introducing this. We've got the support here for you. We've got all of the tools around you to help get better at it, and you've got lots of time after this 6 weeks to do that development work and cement in the concepts. The arty stuff doesn't matter. I'll just submit some working code and bam, HD. Well, our marking criteria includes like making something which is artistically sensible, so the arty stuff does matter, and that's why we have a whole course about it. We've gotten pretty much to the end of the lecture. There's some important further reading and watching here, mainly the Lab 1 content and the P5 reference, which I've talked to you about. You've got your to-do list. I've talked all about this. Get set up with the tools in Lab 1, start learning the vocabulary, and start your assignment 1. Have a look at the website. We'll look at that later in the week. And then you can practice, particularly using that in-browser editor that I showed you. It's really fun to practice with P5, making different little artworks with it. Be empowered about this course. Tell me what you need to know. Tell me what you need to learn in order to make the thing you want, and you'll have a much better time. One way about being empowered is by becoming a course rep. If you're new to the ANU, every course will have a couple of representatives who communicate information directly from students to the lecturers and to the management. I don't have a form for you right now, but if you send me a private message on the forum, we can make it happen. So I'm looking for a couple of course reps, maybe 3 or 4. And any questions? I'll start going back through the old questions and answering them in a minute. Thank you very much for coming to the first lecture. This is the kind of official outro. I think I'm running out of voice, so I might switch to answering questions in text, if that's okay. And then that means I get to switch it over to the outro music. I wonder where my remote controller is gone. I'll find it in a minute. There's been some great questions about sort of the details of these programming systems. And although those are things which we potentially will get to, sometimes I get computing students in here who want to approach this from the perspective of someone who already knows a lot about Java or has done some programming courses before. Maybe just take this first lecture at face value. I'm giving you these tools in P5. This allows you to create artworks. Please go ahead and try it. Oh, Jean McClay is giving a really good recommendation of being a course rep. Thanks, Jean. Songshin Shia says, are we able to create anime-like art? Well, I guess so. That would be a lot of rectangles and ellipses. If that's what you want to do, we have the tools here, but also the focus in this course is not make anime-like art, it's make interactive art. So I do find people sometimes come in with a preconceived idea of the kind of art they want to make, whether it's something like anime, something like a video game, something like a movie, but none of those things are really interactive art in the same way. So we do have lectures to teach you about what that is and help you find good ways to do things, but it is sometimes a little risky to have that preconception. Be open-minded about what kind of art you can make in this course and you'll have a better time. Are these pictures created by using Java? This picture right in front of me, no, that's a photo. I created that with a camera and with the real world. Sorry, I don't have any huge number of backgrounds I've made in P5. I did make this one in P5. The intro and outro animations were made in P5. So that's something. Can we think of P5 as a plugin library? It is a library. It's a JavaScript library, yes. I'm trying to find some other, I think I answered how do we fade in color. Will the storage be in private mode? I'm not sure what the answer to that question is. Is it possible to import a pic and manipulate? There are ways of doing that with P5. Someone was asking about order. Is the earlier code, the code that's upwards in the file, is that drawing relatively bottom patterns in the image? Well, it's maybe drawing things that are further away. You can think of these shapes as being away from you and then another shape on top and another shape on top and another shape on top. And that's right. Code which is higher in the file will tend to be behind those things. But it does get more complex, as we'll see in later weeks. Can we use curves for name tag? Yep. You can use curves in your name tag. You can do literally whatever P5 stuff you want in your name tag. I'm going to go to I said I wouldn't do it, but I'm going to the assignment. Assessments, assignment 1 name tag. As long as you follow these 3, your name tag needs to have the following. It actually needs to be a square, 800 by 800 square. It needs to have your name on it. It needs to be interesting, and it needs to be readable. Those are our specifications for name tag. Yeah, I have made some P5 art for my background because I thought it would be fun. Pratima's asked, how do we keep something private? Well, the editor sketches you make are sort of private. I guess you can share them if you send someone the URL, the website, it can be shared. You can make it private if you make an account and keep it private, yep. I might save that one for later. Stay on page, I'm going to save it. Give it a name. I'll share with you my sketches later so you can see. If you want to keep something absolutely private, well, you can download the Lab 1 and repo onto your computer, edit that code, it's now on your computer, and it is private, yeah. And this little website, Go Live, that's running a website just inside your computer. It's not a website that other people can go to. It's a private web server running within your computer. Only you can access it. It's completely private. Yep, 4 gigabytes will be fine. Okay, now I'm going to wind this up, so I think I'm going to go to my outro for a little while. Folks, thank you very much for coming to the first lecture. I really appreciate it. I'm only 5 minutes over time, so that's not too bad. We ended up using the whole 2 hours, wouldn't you know it? It was nice to have time to go through a few demos and answer some questions in real time. So I really appreciate your time today. If you have any more questions, ask them on the forum. That's the place to ask them.